Hi, I'm Phil, and we're going to continue with our series of projects on other projects for session 3 of the seniors robot course. So if we go to our bubble on the mind map, we've got other projects. We've already done traffic lights, and we're going to do garden control now. And there are 3 projects I'm going to demonstrate. One is starting off with water and with light. Then we're going to combine the two of them, and there'll be desktop demonstrations where you can see those. So let's have a look at the first of our water projects. So in this project, we'll just collapse all the bubbles. Here we go, collapse. They're all, and we're right on the desktop. So you can see what my desktop looks like. For my water control, I've got 2 glasses. One is full, and that's the tank, and that's on the left. And on the right, we have our soil, represented by a empty glass. And the idea is that when the soil is dry, we're going to pump water from the tank into the soil. And this is the hardware that we'll be using. So the objective is detect if the water level is below the threshold, that is, the soil is dry. And we're going to use dryness scales from 0 to 100. So 100 represents very dry soil, and 0 represents full water in the soil, plenty of water. Hardware, we're going to use the Atom S3R, and we've covered that before in a lot of detail. So we're using the same computer for all of these projects. On the units, we're going to use a watering unit, and that comes also from M5Stack. And the cost of that is about $11.50. And we'll also use the atomic motion base, and our Atom S3R fits on top of that. But we're not going to use any of the motion control. That is, that controls a motor or 2 motors and servos, up to 4 servos. We're only going to use the expansion ports, that is, access to port B and C. And our connection is quite simple. We'll just go back to the top, and you can see what it looks like. So we insert our Atom computer into the Atom motion base, and we're going to connect a Grove cable to the watering unit. So you can see that here. And this is our other labels for our ports. So we've got access to port B and C, and you can see that we need to use the GPIO 5, 6, 7, and 8 for ports C and B. So when we do that for watering, we're going to put that onto an input of 7 and an output of 8. And so we select the resources, and we're ready to initialize our software. So this is what the software looks like on our UI Flow version 2. And on setup, we're setting up the watering unit, and we set the dry maximum to 100, the dry minimum to 90. So the dry minimum, if it's less than 90, it will turn the pump off. And anything above 90 will switch the pump on. And we can track the state of the pump with the pump state, and we set that at false. In our main loop, we go and get the analog to digital conversion level. It's a raw value from 0 to 32,000, but we're going to remap that and round it up from 0 to 100. And the next one just looks at the dry level. If it's greater than the minimum and we've got the pump state true, we then turn on the pump. Otherwise, we turn it off. And we show the status of the pump on label 3 and the pump state on label 5 on our Atom LCD. Then we just wait a second. And we have an event function. And when button A is pressed, it just toggles the pump state value from false to true or true to false and shows that result on one of the circles of our LCD. And stay tuned and we'll have a look at what that looks like. But overall, I was able to detect water. When it was dry, it turned on the pump. And when it was more than 90 in the soil, it turned off. But when it was less than that, that is, it was no longer dry, it turned off the pump. Here we have the garden watering demo, and we're using a computer from M5Stack, the Atom S3R, and it's on top of a Atom motion base. And we're not using the servo or the DC motor. We just want access to port B. And we also have another port on the other side, port C. And connected to port B is the watering unit. So we have a pump on top and a soil moisture. So we've got very dry soil here, and over here we have our tank. And the idea is on our screen, we're showing the status of the pump and the status of the soil. So at the moment it's 100% dry, and we can activate the pump by pressing the button on the Atom computer. So you can see the water is now going in, and the dry value, it should be getting a different value. So you can see the dry level is going down, and we've actually filled up more of our soil. Our soil has all the water that was in the tank, and that's our watering demo. So let's move on to light projects. And in this project, just closing down all of the bubbles, we're going to measure the light value in lux and provide a light switch and lamp. So the idea with this is that we can supplement the ambient lighting with some extra lighting from our LED flash. And hardware-wise, what we're going to use, again, is the Atom computer. The units this time will be using a flash light unit. And this is normally used with digital photography on a camera, a digital camera. It gives us more light than you would normally get from a standard demo LED. And we're going to use a Dlight unit, and that's going to measure the light in lux. So just looking at the specs on that, that's our, and you can see the interface for that is an I to C interface, whereas our flashlight unit is using a GPIO. The cost of the Dlight is $5.50. And let's have a look. We'll need a few cables for all of that. So we've got 2 units, so we'll need 2 cables. So we should really change that so that we've got two Grove cables. And the connection, if we look at how we're mounting the Atom computer, it goes on top of the Atom motion base, and we've got access now to port A for our digital light unit for measurement, and our flashlight goes onto port B. So these are the connections you can see that we'll be using GPIO 5, 6, 7, and 8, although we won't be using port C, so we're mainly using GPIO 7 and 8. So let's go across and have a look at the software on that. There's our, when we're painting the LCD on the Atom computer, we're going to put the lux value into label 1, and the status of the lamp will be shown on label 3. And when we press the button, button A, we will show the status on that in the circle. So when we use UI Flow 2 on Chrome, we need to call up the extra resources for our units, and the internal software needs to access the pins and the button. So let's have a look at the code. So the code for this is shown here. Let's see, we can fit it all on. Yeah, we've got on the top, we're initializing our hardware. Since we're using an I2C, we need to set that up to the correct pin numbers. And since we're using the flashlight, we're going to use pin 6. So we're not really using pin 5. That could be available for sensing something else. So similar to the water unit, we go and grab our digital light measurement, round it up, and that's already calibrated for us in lux. And we show that on label 1, and we can show the status of our light switch on label 3. We wait 1 second and just repeat all of that. When we press button A, we're going to toggle the light. Will either go on or off, depending on the value of our light switch. And we've got 2 functions. In turn the light on, we show the status, and that status will be true, and we turn pin 6 on. And we do the opposite when we turn the light off. So those 2 functions help with our light control. And this is quite a simple program for controlling a light in our garden. So we were able to get the results. It executed okay, and I was quite happy with the results. We detected light, we measured the light in lux, and we provided a light switch and lamp for our plant. And that's the light switch. In our third project, we're going to combine controlling water and light. So let's have a look at the project. The desktop looks like this. And what we have is on the left, we've got a water tank. And on the right, we've got our soil. In the soil, we have a watering unit that has a combined water pump and a soil moisture sensor. In the middle, we have our Atom computer sitting on a motion base, and that's connected to a digital light meter and also to a LED flash light. And a little bit more on that. Let's see if we can see some more pictures before we go into the detail. So everything's mounted on Lego. So here's our water tank, and in the middle we've got our computer on the motion base. There it is. Here's our flashlight. So that's what's on our desktop. So let's go and have a look at the objective. We'll just increase the font so you can see that. So the objective is to detect light level and measure it in lux and let the computer know what that value is. We'll provide a light switch and a lamp, and that will provide our plant with extra light. The water plant, we're going to water the plant for the first minute of every hour. So we don't want to drench it. If it's already got too much water, the pump will not turn on. Design-wise, we're going to use the digital light meter and the flash unit. We're also going to use the water moisture sensor and pump. And we'll provide a little bit more support for debugging the program with some data on our computer LCD. So hardware-wise, we're going to use the same computer, the Atom S3R, and we've covered that before. The units, we're using the flashlight unit, the Dlight unit, and the watering unit. You might notice that the Grove socket on these units are color-coded, which means when it's black, it's a GPIO support, and we need a GPIO pin from our computer to be connected to it. For our watering unit, we need two of the pins, one for sensing the water level and the other one for controlling the pump. The Dlight uses a connection to the I2C bus, and that's why it's red. So the cables, we'll need 3 cables, one for each of the units that are used. And just looking at how it's all connected together, on port A, we've got our digital light unit. On port B, the flash unit. And on port C, the combined moisture and pump. And our Atom sits on top of the motion base and controls all of those ports. So the combination, you can see, we're going to use the ports C and B. That's GPIO 5, 6, 7, and 8. Okay, so we might have a look at that. Port, the moisture is going to use G7, the flashlight G8, and the pump will be on port C, and we'll use G6, and we still have an additional port left over, G5, and we're not going to use that. So let's have a look at the software. I'm going to use UI Flow 2, and the first thing I did was to paint the UI on the Atom LCD. So you can see we've got the name of the program, the version number right on top, and on the next line we have LU for lux, and that will show on label 1 the light level in lux. Next to that on the right, we've got a debug support that shows us the countdown. So it will show the minutes, and when it's 0, it will automatically switch on the pump if the pump enable switch has been turned on. We've got the lamp status on label 8. Just coming down, soil D is for the soil dryness level, and we have the pump status, and we've got the buttons, the circular buttons right on the bottom show the status, and that we can turn on and enable the pump with the button A on the Atom computer. So resources, we have to set up UI Flow to use the ADC, the pins, the buttons, and the timer. So we're going to use the timer and not the real-time real-time control. Code-wise, this is what it looks like on UI Flow. So if we go across to the Chrome browser and onto the M5Stack website, then select Software and UI Flow 2, we have access to the program. So on the top left, we set up, and just under that we have our timer callback. And in the middle column, we start off with the loop, and there's a number of additional supporting functions, starting off with the turn the light on, update the display, check alarms, and on the right column, we've got 3 extra functions. The first one is check the light level, check the soil level, and right at the bottom we have an event function. So when we press button A, we then toggle the value of the pump status, either true or false, and show that result on circle 0. The light switch will be shown, the status of the light switch will be shown on the next circle just to the right of that. So starting off, what we would do is paint the screen with the UI. If we go across, this is what it looks like. And we're using almost all of the real estate on that LCD of the Atom computer. Then after that, we've got nothing for our communications, but hardware-wise, we're going to use the ADC, and that stands for analog to digital conversion. We need access to the pins and the button switch, and we might also use the pin buttons. We don't really need the IMU, so that could actually be switched off. We do need the timer, and we're not really using the real-time clock. So we might just confirm all that. And we're going to use the Atom base. So if you look at the Atom bases, we're going to select the motion base. And it's going to set up the I2C port on 38 and 39. Okay, so that's been done. And when we look at we also need to select our units. And so you can see the 3 units are added, the Dlight on the I2C port, and on the flashlight, we've got G1 and G2, and the watering is on G5. Okay, so there's obviously a conflict there. So it's not that critical because we'll be addressing the pins of the flashlight and the watering separately. Okay, so if we just move off our and return to the, so we're returning to setup, and you can see we're setting up the pins. Pin 7 has been set up for an attenuation level. This is where our ADC lies. Port 6 and 8 are being set as outputs. And we've got our I2C port set up, and we're also setting up the dry maximum. So when the soil is really dry, it's 100, and when it's less than 90, it will need water, and at 0, it's full of water. We have the pump status, and initially we turn the light off. We set up our timer, and that will interrupt every 1 second. And then it will maintain a clock on the timer callback with seconds, minutes, and hours. So we could actually change that to schedule when we want to turn on either the light or the water control. In loop, we go through a number of functions. The first is to check the light, and there's a function that handles that. Then we check for alarms. We then check the soil and then update the display. So when we're updating the display, we just simply take the parameters of digital light, the status of the light and the soil level and the pump all go to our LCD. When we check an alarm, we're just simply looking at the minutes, and when it equals 0, we turn the light on. And in this very simple schedule, we're only looking at light control. But we could actually have this scheduled for a particular time in the day or for various times in the day. But this is just a simple example. When we check the light, we just simply get the measurement from the Dlight unit and set that up to light lux. When we check the soil, we get the ADC measurement, which is on pin 7, and we set that up by remapping the values so that the soil dry level goes from 0 to 100. 100% means the soil is really dry. And if the soil dryness is less than the minimum, which is 90, and the pump state has been enabled, it will turn the pump on via pin 8, or otherwise it will turn it off. And we enable that pump state to change by pressing button A, and that will toggle the value and show the result on circle 1. And it'll also show the light level on circle 1. So circle 0 for the pump state and circle 1 for our light switch. And that's the software for our light and water control. This is the garden water and light control. And we're using an Atom computer, and it's sitting at the moment on top of a motion base, which also provides access to ports B and C. And on port A, we've got a digital light sensor, which gives us the measurement of light in lux. And on port B, we have a watering unit, and it's a combined pump and soil moisture sensor. And we're ready to do a demonstration. So what we'll do now is switch it on. Okay, so we just go to our switch, power switch, and it's going to initialize. When it initializes, it turns on the light automatically for our plant. And in the demonstration, I'm going to activate or enable the pump. But the pump will also need to have a dry level. So our soil is represented by the glass here, and our water tank is over here. And what we're going to do is use the pump to transfer water when there is no water in the soil glass. Okay, so what we're going to do is switch it on. We can switch it on here with the button, and we can see that the water is now being transferred. And you can take the measurements. The measurements are on the display. We have the light unit at 120 lux. The soil moisture is 89, and when it's below 90, it will turn off the pump which is done at the moment. So the pump is off, and we can also turn it off by switching the light. So that the push button on the Atom is used as an enable for our water and light control. So I was quite happy with the results of our water and light setup and project. And I was able to detect the light, measure it, and control the light with a flash unit, providing additional light. And I was able to enable the pump and turn on watering every minute in the hour. That was my simple schedule. So if you want to take this further, you can calibrate the water rate and the volume that you're using, and perhaps even provide an alarm when you're getting low water levels for your tank. You want to be able to waterproof some of the components, like the digital light sensor, perhaps only expose the area of the sensor itself, but protect everything else. And similarly with the computer and the Atom motion base, they need to go into water tight containers. You could also do some more elaborate scheduling of both watering and light, and perhaps stop any watering at night and minimize the evaporation of the water. And perhaps you could also log the results so you can see what the trends are and if they make any improvements to your plant growth.